I'm Annette, and with this tutorial I will explain what binary is. So the system we usually use in order to count is decimal. It means that we use 10 digits to form all the integers. Those are from 0 to 9. In binary system there are only two digits, only 0 and 1. But before diving into explanations, why do we need binary system? There are several systems such as hex, decimal, binary, and so on. And those differ from each other with the number of their digits. The binary system is mainly used in computers. As you actually might not think, computers are not as intelligent as we think. They only get if something is on or off. So we have a light bulb, which is known as a transistor in computers. It can be either on or off. If it is on, we say that it has the value of 1. And if it isn't, we say that its value is 0. So basically, this is what computers understand, and by giving values to several transistors, we send information to the computer. Now let's understand how do we form all the numbers with only 0 and 1. We had the transistors in our computer, and in order to represent the number 10, we could have turned on 10 transistors. But this technique is not convenient. Just imagine if we had to represent the number million. We had to turn on million transistors, which is not handy. Plus, in the described example, we used only one value, just being on. But why to do so if we have two values? And that is what binary system does. It uses zeros and ones, or is the same as ons and offs, to represent numbers. Now let's start counting. So 0 is 0, 1 is 1. Then all the unit digits in our system, the 0 and 1, are already used. So we add together 1 and 0 and get 1 and 0, which equals 2 in decimal system. The next one is 1, 1, which equals 3 in decimal system. And we have to add another digit again. 1, 0, 0 equals 4, 1, 0, 1 equals 5, 1, 1, 0 equals 6, 1, 1, 1 equals 7, and so on. If you take a closer look, you'll notice the pattern. It's like every time we change the number, 1 floats from the end to the start. See? Whee! 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 Whatever. So now let's understand how to convert a binary number to our decimal system. Because if we're talking about big numbers, we can't just count one by one. Let's take a look at this table. So in the first row, we're writing our, for example, I want to know what 1, 1, 1, 0, 0, 1, 0, 1 is in decimal system. In the second row, we are writing the IDs, like backward. Like the last one has ID of 0. Next one is the first one, then is the second one, third, fourth, fifth, sixth, and seventh. Here in the third row we have to write powers of 2 respectively, like the first one, 2 powered by 0 is 1, 2, 4, 8, 16, 32, 64, 100. In the fourth row, we have to write the product of the third row and the first row. In other words, we're seeing if it's 1 or if the transistor, let's say, is on. We are counting the number in the third row. 2 powered by its ID. For example, the first one is 1, we write 1. The second one is 0, so we don't have to write these 2. So we don't write anything. Then it's 1 again, so we write 4. 0, 0, write nothing. Then 3 ones. So here, 64 here, and 128 here. And in the fifth row, we have to write just the sum of the fourth row. So it is 229. So we found out that 111000101 in binary is equal to 229 in decimal system. Let's check. Over table 111000101. Yeah, and you just could have used the calculator, but sorry, the programmer one. That was basically it. Thanks for watching. Bye.